Okay, now first of all, what are the types of conductors? One is simply you can call it conductors or good conductors. Second one is the insulators or poor conductors. Okay,
Yeah.
and in between there is a third class of substance which is known as semiconductors. Okay, good conductors will be those which will be metals. They will be possessing either 1, 2 or 3 electrons in their outermost shell. So these are free electrons that will be able to conduct electricity very well. Insulators will be those materials which will not be able to conduct electricity at all, or they will be very poor conductors of electricity.
Okay.
These will be non-metals or materials like rubber, plastic, glass, etc. Semiconductors are those materials which will be having 4 electrons in their outermost shell. Okay, the best of this example is silicon and germanium. Okay, now these are the elements which are known as semiconductors. It means they are not very good conductors also, and they are also not very poor conductors. Now because they have 4 electrons in their outermost shell, okay, these 4 electrons in their outermost shell, for example, if I'm considering silicon, the 4 electrons can be shown like this. I'm showing only the outermost shell. Okay, now when you are going to mix it with another substance, that is, you are going to create a material that will be known as an alloy. Okay, we are going to add to this material like phosphorus.
Okay.
Phosphorus, as you know, it has 5 electrons in its outermost orbit. Okay, so there will be an extra electron. If this silicon is going to get bonded with phosphorus, okay, I can show this with a different color. This is the atom of silicon, this is the atom of phosphorus.
Yeah.
The 4 electrons in red I have shown, and there is going to be a 5th electron. Of course, then this is also going to get bonded with another atom of silicon like this. Okay, now but this extra electron that is there, this electron will now be responsible for conduction of electricity. This process in which we are adding another element to a semiconductor, this is known as doping.
Okay. What is doping again?
Doping is addition or alloying of an element with a semiconductor. Okay, now semiconductor, obviously we have seen that they will be having 4 electrons in their outermost shell. Doping, if it is done with an element which is having an extra electron. Okay, now this
Yeah.
electron, what kind of charge the electron is having?
What do you mean by the type of charge?
Positive or negative or no charge?
Oh,
No.
phosphorus is negative.
Silicon, see, when you are considering a neutral atom, there will be 14 protons and 14 electrons.
Yeah.
So at that time, it is not going to carrying, it will not be carrying any charge. Okay, but now here there are 15 protons and 15 electrons. That extra electron which I have marked over here, it's going to carry what type of charge? It is going to carry a negative charge.
Okay.
This kind of doping that is done where you have added negative charge, this is known as end doping.
Okay.
All right. Now we can
Yeah.
also have an element like say aluminium. Aluminium, the electronic configuration is 283. Now it is having 3 electrons in its outermost shell. Even you can have boron, okay, which is going to have electronic configuration 2 3. So in the outermost shell there are going to be 3 electrons. Is a gap that is left because there is shortage of 1 electron, because you see when you are having silicon, it's going to have, okay, the silicon atom which is there, it is going to have 4 electrons in its outermost orbit, while this atom like aluminium which is there, or even boron which is there, it is going to have 3 electrons in its outermost shell. Now here there is a gap that is left if you are bonding it with silicon, because silicon which is there, it is going to have 4 electrons.
Okay.
Okay, of course these all atoms will be again surrounded with aluminium atoms. So now here there is a gap that is left. This is going to be known as p-type doping or p-doping.
Okay.
Okay. Now when you are going to join both of these, all right, suppose here I'm going to have on one side there is an alloy which is bonded with silicon with boron, and this is joined with another material over here which is the combination of silicon and phosphorus. Okay, this type of a material is known as n-type because there is an extra electron. This type of a material that is known as p-type, and when you join both of these together like this, we are going to call this as p-n junction diode.
Okay.
Now this type of a diode that is there, the basic function of diode is it will allow the current to flow in one particular direction only. So if there is a reverse current, the current will not be allowed to flow. Okay, that is the function of a p-n junction diode, or simply you can call it diode. It will allow the flow of current in one particular direction only. Okay, and if this diode
Yeah.
emits out light, then we call it light emitting diode. Which in simple language we call it LED.
Yeah.
Okay, LEDs you will be able to see everywhere, starting
Yeah.
from the remote, your TV set, even the
Yeah.
switches or buttons that are there on your computer, on your laptop. Okay, these all the light that is emitted, that is going to be known. These are diodes which will be LEDs that are light emitting diodes. Basically,
Yeah.
a p-n junction diode is the one which will allow the flow of current in one direction. Okay, a capacitor is a device, an electrical device which causes a delay in the flow of charge or in the flow of current. How this delay is caused? Because it has ability to store charge. Okay, we'll just compare it with the symbol of a battery.
Wait, I don't understand. Why do you use delay?
1 second, I'll just come to that point also. First we'll just take up the symbol. You can see here in case of a cell, one line is longer which is going to represent the positive terminal. The other line is shorter one which represents the negative terminal. Obviously it causes the electric current to flow, or it simply is a source of energy which provides potential difference. A capacitor will be represented like this. Both the lines will be equal in size. Okay, now it stores charge. What does it mean? Now suppose there is a current flowing say in this particular direction, say from A to B. Okay, then what will happen here? There will be some such material that for some amount of time or some quantity of electrons or some quantity of current, that is charge, it will be able to store until it has reached its maximum capacity. After that, it will allow the flow of charge. Okay, once that capacity is reached. Now, where do we find these the use of these capacitors? You must have seen those cameras in which there is a delay in which an auto flash or photography takes place after say 10 seconds.
Yeah.
You just press the switch and you just go and sit over there, and after 10 seconds a photograph is being taken. Okay, so that is the function of a capacitor. It causes the delay. That the reason for that is because it has ability to store charge. There are some materials that are placed inside this so that that much storage of charge is possible. After that much time delay that has taken place, or when its capacity is reached, then the current flow will be allowed. What a diode is? Diode has two terminals while a transistor has three terminals.
Okay.
Okay. Now, first of all, the representation of a transistor. Okay, a transistor will be represented like this. I have marked the arrow over here.
Yeah.
The left hand side of this part is known as the base. Wherever arrow is there, that terminal is going to be the emitter. And the other term is the terminal is going to be the collector. These are the three names given to the three terminals of a transistor. Okay, now what is the basic function of a transistor? A transistor basically acts like a switch. Okay, now how this transistor acts like a switch? Okay, basically here there are three terminals. I'm just going to show the circuit later. The base that is there, whenever the current is flowing through the base, then the current will flow through the emitter as well. When there is no base current, okay, then it is going to be off. The transistor is going to be in the off position. Okay, we are just going to
So whenever there is a base
current is there. Yeah.
Whenever there's a base current, it will indicate that it is on.
Yeah, the current will flow through the circuit and the condition of this transistor is going to be on position. Wherever there is no base current, okay, no current can flow through the transistor, then it is going to be in the off position. Okay, we are just going to show the circuit for this. Alright, before we go into that circuit, I'm just going to explain you one more thing, that is going to be a thermistor. Okay, we have seen there are two types of conductors. One is ohmic conductors and the other ones are non-ohmic conductors. An ohmic conductor is a conductor which obeys Ohm's law.
Yeah, we did this last class, right?
Okay, it obeys Ohm's law. And a non-ohmic conductor is the one which does not obey Ohm's law. Okay, transistor is a device which is going to come into the class of non-ohmic conductors. Okay, generally for all metallic conductors, as the temperature increases.
Okay, so temperature is inversely proportional to resistance.
That is for thermistors. Here, as the temperature increases, resistance also increases. For non-ohmic conductors, that is for specifically for an example.
It's inversely proportional, right?
As the temperature increases, then the resistance decreases. Okay, so we are going to use a thermistor over here and with the help of that we are going to explain the condition of a transistor when it is in on position and when it is in off position. Okay. Now let us take over here the circuit that is drawn for transistor is I'm drawing two circuits side by side. This is your base, this is your collector. I'm putting an arrow on this side, so this is your emitter. This is the source of current. The representation of a thermistor, basically a thermistor will be represented like this. Okay.
It's a variable resistor, right?
No, variable resistor will be represented like this. Either you can show it this way or variable resistor can be shown like this. These are the two representations of a variable resistor. Okay. This is thermistor. I'm going to put the thermistor at this position. This is connected over here. Another resistance is also there over here. Simultaneously, I'm going to draw another circuit for transistor. This is your collector, this is your base. Sorry, this is your emitter. This is your collector. Again, a transistor is shown over here. I mean the thermistor. The resistor also will be there. Okay, this is the first case. This is the second case. At the moment, both of these diagrams look alike. Let us say in the first case here there is low temperature. Okay, now when here there is low temperature, what can you say about the resistance of the thermistor? The resistance is large. So there will be no current through the base through this path. When there is no current through the base through this path, okay, the current cannot flow even through collector or emitter. It means here the transistor is in off position. The temperature is low, it means this thermistor which is there,
Yeah.
okay, is going to have high resistance. If the resistance is high, it means the current will not be allowed to flow through this path. If the current is not flowing through the base, then the current will not even flow even through the emitter. It means the transistor is in off position.
Okay.
Alright, now let's take the second case, second diagram which we have drawn. Suppose here the temperature is high. When high temperature is there, thermistor, obviously the resistance will decrease. If the resistance decreases, now the current starts flowing through the base.
Okay.
Current starts flowing as because here base current is there, emitter current also will be there. It means the transistor is going to be in the on position. When the transistor is in on position, we can, in the circuit, we can apply a buzzer over here like this. Okay, the current is on. This is going to be a large current that is going to flow through the emitter. Of course, the small base current controls it. Once the current flows through the emitter, this buzzer will start ringing. When does the buzzer start ringing? When the temperature is high. Okay, when the temperature is high, the
low resistance and then increasing current through the transistor, causing the
current through the base starts flowing a small amount of base current starts flowing, that turns on the transistor. The large amount of emitter current also starts flowing, that rings the buzzer. Okay. Now this type of a circuit can be used as a fire alarm. Right? Because when
Yeah.
temperature is there, the current is not there. It means the buzzer will be in the off position as the transistor is in off position. When there is high temperature, the resistance of thermistor, which is over here, it decreases. As the resistance decreases, now the base current starts flowing. When the base current
Yeah.
starts flowing, small amount of base current starts flowing. A large amount of emitter current is also allowed to flow, ultimately turning the transistor in on position, and that rings the buzzer. This is the circuit for a fire.